This videotape deals with solving systems of linear equations in 3 variables. Let's assume we have 3 linear equations in 3 variables, the same 3 variables, x, y, and z. We're interested in the solution set for this system of equations. By that I would mean the set of all ordered triples, x, y, z, that satisfy all 3 equations in the system. Let's start by looking at an example. Okay, let's consider this system of equations. X plus y plus z equals 6. X minus y plus 2z equals 7. 2x minus y plus z equals 6. We have a system, 3 equations in the same 3 variables, x, y, and z. Let's label these equations 1, 2, and 3 for future reference. Okay, now what we're going to try to do is to reduce this system of 3 equations and 3 unknowns into one involving 2 equations and 2 unknowns, which we've already learned how to solve. If you don't recall that, I suggest you view the preceding videotape. Okay, and the trick, the main idea, is to take 2 different pairs of equations and eliminate the same variable from each pair. Take 2 different pairs of equations and eliminate the same variable from each pair. Now there are 3 possible pairs of equations. We could take the first equation and the second. We could take the first equation and the third, or we could take the second equation and the third. 3 different pairs, 3 different groups that we could make of 2 equations each. We want to take 2 different pairs. Okay, so take 1 and 2, and then take 1 and 3, and eliminate the same variable from each pair. This will result in 2 equations in 2 unknowns. For example, we can see here that if we were to add equation 1 with equation 2, when we add these 2 equations, the variable y would drop out because the two y terms here, one has coefficient +1, one has coefficient -1. Okay, so we could eliminate y from equations 1 and 2 very simply. In a similar fashion, we could eliminate y from equations 1 and 3 also very easily by adding equations 1 and 3. So we would therefore have 2 equations, both involving only x and z, which we could then solve for these variables x and z. Having found that, we could substitute in any of the equations to figure out the third variable, y. Let's try this. Okay, I'm going to add equations 1 and 2. Okay, now in a more complicated problem, I might have to multiply equation 1 both sides by some number, and multiply equation 2 both sides by some non-zero constant, and then add. In other words, the idea is that when we add the equations, okay, after they've been multiplied by appropriate constants, if necessary, when we add the equations, one of the variables should drop out. We then work with another pair of equations and fool around with them until the same variable drops out. This leaves us with 2 equations involving only 2 variables. Okay, so we take equation 1 and equation 2. Equation 1 was x plus y plus z equals 6. And equation 2, x minus y plus 2z equals 7. We add equations 1 and 2. The y drop out, and we get 2x plus 0y. Okay, 2x plus 3z equals 13. Here we have an equation just involving 2 variables. Okay, we can, if we want, call this equation number 4 for future reference. Okay, so we took one of these 3 pairs. We took equations 1 and 2 here. Okay, now we would like to eliminate the same variable, we're eliminating y, from another pair of equations. Now, if you work with equations 2 and 3, you'll have to first multiply, say, equation 2 through by -1 both sides, so that when you add, the y's drop out. Whereas if you go into equations 1 and 3 immediately, then just by adding, without doing anything else, the y's will drop out. So let's work with 1 and 3. That'll be our second pair. Equation 1, that's x plus y plus z equals 6. And equation 3, 2x minus y plus z equals 6. We add these two equations. We get a fifth equation, let's say, 3x, the y's drop out, plus 2z equals 12. Okay, we have now produced two equations involving only the two variables x and z. Okay, we can solve these two equations in two unknowns by the method we learned in the preceding videotape. Find x and z, and then substitute into any of the original equations to figure out what y is. Okay, so let's look at what we have. We have equation 4, which is 2x plus 3z equals 13, and equation 5, which is 3x plus 2z equals 12. Okay, now, in the last videotape we learned that if we would like to eliminate one of the variables, a case like this where if we just try to add them like this, nothing gets eliminated. If we were to say multiply both sides of the top equation by 3 and both sides of the bottom equation by -2, okay, if we do that, we will get a plus 6x here, a minus 6x here, and when we add the equations, the x's will drop out. Okay, so let's do these multiplications. Multiply both sides of the top equation, which is equation 4, by 3 here. We get 6x plus 9z equals 39. Now multiply both sides of the bottom equation by -2, so minus 6x minus 4z equals minus 24. Now let's add the equations. Minus 6x and plus 6x just gives us 0. 9z minus 4z gives us 5z equals 39 minus 24, which is 15. We divide both sides of the equation by 5, and we get that z equals 3. Okay, now that we have z equals 3, we go back to an equation involving, say, x and z. In other words, just involving two variables. Let's say we go back to an equation involving x and z. Since we know what z is, we'll be able to find x. And once we know x and z, we go back to an equation involving x, y, and z and figure out what y is. So let's do that. Okay, z is equal to 3. One of the equations involving x and z was, for example, 3x plus 2z equals 12. You could use either equation that we had involving x and z. We let z equal to 3, and we get 3x plus 2 times 3 equals 12. 3x plus 6 equals 12. 3x equals 6, subtracting 6 from both sides of the equation. X equals 2. So we have x equals 2, z equals 3. Now all we need is one of the equations involving all three variables. For example, the first equation, which was x plus y plus z equals 6. Since we know that z is equal to 3 and x is equal to 2, we get 2 plus y plus 3 equals 6. Y plus 5 equals 6. Subtracting 5 from both sides of the equation, we get that y equals 1. So we have found what we believe to be the solution to the system. X equals 2, y equals 1, z equals 3. Okay, so for our answer, we're going to have to check it, but we believe that 2, 1, 3, that ordered triple, meaning the first number is x, the second is y, the third is z. X equals 2, y equals 1, z equals 3. We believe that that is the solution. Let us now go back to our original system of equations, okay, and check our answer. Okay, we believe the answer is 1, 3. X equals 2, y equals 1, z equals 3. So we check. Now in equation number 1, we know that, of course, is going to work. We used that just a moment ago. X plus y plus z should be equal to 6. 2 plus 1 plus 3 should be equal to 6. 6 is equal to 6. That's okay. Equation number 2. X minus y plus 2z equals 7. X, which is 2, minus y minus 1 plus 2z plus 2 times 3 should be equal to 7. X minus y plus 2z should be equal to 7. 1 plus 6 should be equal to 7. And of course, 7 equals 7, and that checks out. And finally, the third part of our check using equation number 3. 2x, which is 2 times 2, minus y minus 1 plus z plus 3 should be equal to 6. And we have here 4 minus 1, 3 plus 3, 6 equals 6. And that checks out. Okay, so we have, in fact, found the solution to this system of 3 equations in the 3 unknowns x, y, and z. Reviewing our system, we took a pair of equations and eliminated a variable. In this case, we eliminated y. We took equations 1 and 2, added them together, and eliminated the variable y. We then wanted to eliminate the variable y from another pair of equations, and we chose to use 1 and 3. If we add 1 and 3 together, y also drops out. This left us with 2 equations involving the 2 unknowns x and z, which we then solved by the method of elimination in the previous videotape. We multiplied the top equation, both sides, by one number, the bottom equation, both sides, by a number, so that when you add the 2 equations, one of the variables, in this case the x, was eliminated. We then were able to solve for z. We substituted into any of the equations involving x and z and found x, and then back into one of the original equations involving x, y, and z to find y, and then we checked our answer. Once again, 3 equations in 3 unknowns. 2x plus z equals 4. X plus y equals 2. 2y plus z equals minus 4. Equation 1, 2, and 3. These 3 equations involve the variables x, y, and z, and we would like to solve, possible. Okay, solve the system. Okay, first thing to notice is that we have only 2 equations in the first, 2 variables in the first equation, 2 in the second, and 2 in the third. This problem actually should be easier to solve than the one that we just did, but because of the way it's written, some people find it more difficult. The first thing I would suggest doing is to rewrite the equation so that the variables are lined up under each other. In other words, 2x, leave space, plus for y, plus z equals 4. X plus y equals 2, and 2y plus z equals minus 4. This is equation 1, 2, and 3. Help us to recognize exactly what we have. Okay, now we already have, for example, an equation involving only 2 variables. Say equation 3 involves only the variables y and z. We would therefore like to get another equation only let's say equation 2 involves only the variables x and y. We would like to get another equation involving also only the variables x and y. We would like pairs of equation. We notice that z appears in the first equation and in the third equation. Okay, we would like to eliminate z from the first and third equations. Therefore, we'll have 2 equations and 2 unknowns. Let's look at it again. We have an equation, for example, the second equation, only involving x and y. Okay, it's easier than the other one. The other time we had to work with 2 pairs of equations and try to eliminate the same variable from each. Here we start off a little easier. We have already an equation in which z is eliminated from. We now would like to eliminate z from one pair of equations, for example, 1 and 3, so that we'll have 2 equations only involving x and y. And that can be done very simply if we were to multiply both sides of, for example, equation 1 by minus 1, and then add that to equation 3. Let's try it. Okay, we will take equation 1, 2x plus z equals 4. And we will take equation 3, which is 2y plus z equals minus 4. Let us multiply both sides of equation 1, okay, by minus 1. So we will get minus 2x minus z equals minus 4. We're multiplying both sides of equation 1 by minus 1. So we get minus 2x minus z equals minus 4. I now want to take equation 3 as it stands here, namely 2y plus z equals minus 4, and add these equations together so that the variable z is now eliminated. We get minus 2x plus 2y, the z's drop out, equals minus 8. And I'm going to use this in conjunction with equation 2, which was x plus y equals 2. I will solve this system of two equations in two unknowns. Okay, I took equation 1 and equation 3. They both had the variable z and eliminated z, okay, from those two equations. I also had another equation, equation 2, okay, that had no z in it, only involving x and y. I now have two equations in the two unknowns. Let us multiply both sides of equation 2 by 2 and add it to this equation here. We multiply both sides by 2. The first equation we're leaving alone. That's minus 2x plus 2y equals minus 8. This one we're multiplying through by 2. We get 2x plus 2y equals 4. We then add equations and get 4y equals minus 4. We've eliminated the variable x from these two equations involving x and y. We now have an equation, only one unknown, y. We divide both sides by 4. We get y equals minus 1. We then go back to equation 2, which said that x plus y equals 2, and say if we know that y equals minus 1, y equals minus 1, x plus y equals 2, that's equation number 2. Y is equal to minus 1, therefore x must be equal to 3. Adding 1 to both sides of the equation. So we now know y, we now know x, and we would like to find z, so just choose any equation involving z. For example, 2x plus z equals 4, which is equation number 1. We now know what x is, so 2 times 3 plus z equals 4. 6 plus z equals 4. Z equals minus 2, subtracting 6 from both sides. So we have x equals 3, y equals minus 1, z equals minus 2 as our solution. And all I'd like to do now is to go back to the original system of equations and to check this answer in the original system. Here was our original system of equations. The answer, we believe, is 3 minus 1 minus 2, x, y, and z. Remember, it's always in that order. Okay, and we check. In equation 1, 2x plus z equals 4. 2 times 3, 2x, plus z, plus minus 2, should be equal to 4. 6 minus 2, of course, does equal 4. In equation 2, x plus y should be equal to 2. X plus y, that's 3 plus minus 1, should be equal to 2. 2 equals 2, and that checks out. And finally, in equation 3, 2y plus z equals minus 4. 2 times y, or 2 times minus 1, plus z, plus minus 2, should be equal to minus 4. And we get minus 2 should be equal to minus 4. And, of course, it is. The answers check out. Okay? And we have found the solution of the system of equations, and that brings us to the end of this tape.